So let's talk about the timing that is related to this register. So remember, the register inside has both a master and a slave. After the rising edge of the clock, we have this sort of notion that the Q output will be changing, and associated with the change in Q is both a propagation delay and a contamination delay. And those are basically the propagation and contamination delays of the slave latch. Okay, because Q is connected to the slave latch, it's the output of the slave latch, and what we're doing is talking about the timing of changes of Q relative to the rising edge of the clock, which is really the only time the Q changes. So a register has those two timing specs, a contamination delay, okay, sometimes in the literature that you buy, it will actually call it the min TPD. That's not a very good name for it, but they're trying to tell you the contamination delay. And then the propagation delay of the latch, how long the so-called clock to Q time of the register. Okay. And then on the master latch front, because remember the rising edge of the clock is exactly when the master latch is going into memory mode. That's when we have to have a period of stability. So we have a setup and a hold time for the D signal in order for the master latch to work correctly. Right, we have to meet the setup and hold time for the master latch. And so we have these four timing specifications. A period of stability for D around the rising edge of the clock. Those are called the setup and the hold times respectively. And then a contamination and propagation delay of the Q output after the rising edge of the clock. Four numbers. And if you ever start doing digital design for Intel, these four numbers will be the things that keep you up at night and how to, you'll earn your money. And why that's true, I'm going to show you in the next couple of slides. Okay, but first let's talk about how we're going to use this in our circuitry. We're going to follow in 6004 a so-called single clock synchronous circuits. In other words, so this is our register symbol here. This is about as good as jokes get in 6004. And the idea is that we're not going to allow any cycles in the circuit. So there's no cycles here except right at the latch itself. In other words, we can have loops, but those loops are always broken by one of these registers. Right? And we know that these devices are all going to be triggered on a single signal. Okay, the so-called, so no combinational cycles. The cycles are all broken by these registers. We know there's cycles, positive feedback loops inside the registers, but we've been working very hard to engineer those so that they work correctly. Okay, we only care about the value of the register data of the inputs to the register here right at the rising clock edge, a T set up before the clock edge, right? So anything can happen in here so long everything is stable, T set up before the rising edge of the clock everywhere in the circuit. So at the time we're changing the state in the circuit, throughout the circuit, basically everything is quiet. It's been quiet for T setup. Right? So we're going to change our memories just when all the other electrical glitches associated with combinational logic, charging and discharging nodes has all died out, and everything's been quiet for a while. So, before the rising edge, someone says, "Quiet, class!" And everybody sits there very silently, and then I say, "Change the state," the rising edge of the clock, and now, all whatever breaks loose as that new signal propagates to the circuit and the combinational logic computes the values for the next state. Okay, so this is actually a very reliable discipline. And in fact, by choosing the clock period, we can make sure that period of quietness is enough to make everything work well. And I'm going to show you that constraint on the next slide. Okay, so what we're trying to do is to adjust our memories sort of at the quietest moment of time. Circuits that have multiple clocks start having issues with the fact that you're changing over here, which might produce some noise just when I'm hoping to update my memory, and that noise might corrupt the value I'm saving. So multiple clocks are actually engineering challenges that you probably have to be careful about.